I'm only recording my screen, not the chat feed. So later when I ask you questions that I want you to put on the chat, feel free to write it. Your name won't be shared online. Okay, what I wanted to do is actually factor this out now. So 2x cubed is the greatest common factor of this beginning question. But I actually want to physically factor that out, which is, like I told you when we were multiplying polynomials and distributing in 2, 1, 2, 2, or 2, 3, I said, here's distribution. Then I said, after we're done, hey, when we go to factoring, it's the reverse. And made the comment, good distributors will be good factors. Because they will know when I take a 2 out of 12, that leaves me a 6. And when I take x cubed out of x to the fifth, that's x squared left over. So the yellow shows what's left over in addition to the numbers, 2 times 3, 6. But hopefully you can just do that by thinking of reverse distribution, what's left over, and then check, wait, am I right or not? Well, distribute it again real quick in your head and figure out that that is correct. 2 times 6 is 12. X cubed times x squared is x to the fifth. Over explanation. That should be plenty for you to understand this, that you don't have to do all of this, but it is nice to see. 8 divided by 2 is 4. X fourth divided by x cubed is x. And then negative 6 divided by 2 is still negative 3. X cubed taken out of x cubed means no x cubes. Okay, or no x's left over. And you can see that in the yellow factors of what was left over after I undistributed. So factoring is undistribution. Okay, factoring, I just don't, facts, what? Factor equals factor. Undistributed equals factor. Okay? All right, good enough. And then I won't let you write this one down. I just wanted to make some points on this, and this is some notes that I had from last period, so I want to erase that. What if you have a negative as a leading term? Then you probably do want to factor out a negative and treat that as a common factor. The reason is, let's go back to this one. When we go to 2, 6 on Monday, you're going to factor out GCFs, and this may very well be factorable as well. The directions will turn into factor completely. With that being the case, you do probably want to factor out a negative if the leading coefficient is negative so that you can see, is the leftover factorable, and it's always easier if that leading term is positive. I kind of don't like what they do with this 2. They turn that into a negative. Really, what I'd like you to think is, if I'm going to factor out a negative 1, that leaves another negative 1 left in here because a negative times a negative equals a positive. Because what if you misidentify that this 2 and this 2 are common factors, and then there's another 2 over here? You might confuse yourself. So it's a weird way of breaking it down. We're not going to do that anyway. We'll just think of it in terms of, we're not breaking down the numbers like this. Let's just say that. And then hopefully you can see that just 1x is a common factor there. So with variables, it's always the lowest exponent on a variable ends up being the variable GCF. The hardest thing you're going to run into if you're not numerate. Now, I don't know if I finished my statement about numerate. What does that word mean? It's synonymous with literate, with English. Literate, you're good with reading, good with, words and stuff, definitions possibly. Numerate means you're good with numbers. I'm going to tell you right now, people that button push and so on and so forth on your calculator, don't even allow your mind to think. That is why we're going to be probably bad at factoring, because your times tables has been lost to you. So hopefully you train yourselves to not use that calculator too much, because it is a problem. All right, so we're actually going to factor this out. Sorry. We're going to factor out a negative 1, and then the common term 3. But I hope you can look at this and say, all right, I don't need to break these numbers down. What goes into 12, 18, and 27? 3 does. 3 goes into 12 4 times. 3 goes into 18, and 3 goes into 27. 4 goes into 12, but it doesn't go into 18. So, we can't have that one. 6 goes into 12 and 18, but 6 does not go into 27. This is the thought process that we want to go through. And I'll answer some questions on the chat after I finish this factoring So we're going to take out a negative. We don't want to write 1, just negative. Negative 3, and then that x. And then we're going to see what's left over. When I take out a negative, this becomes a positive. And then take out an x cubed, take out an x, that means x squared. Then this makes this minus in the middle because 18 divided by negative 3 is negative 6x. And then negative divided by negative is a positive. 27 divided by 3 is 9. And then no x because, and check yourself. Some people forget and they put this x here on accident. And then, they forget. But, negative 3x times 9x is not negative 27x. It's 27x squared. So again, good distributors are good factors because they actually check their answer before they move on. Okay, I'm going to pause the internet video for a second and answer. So resume video going for those that will watch YouTube. Okay, we're going to try these. Oh, I got to get this. Here. Then boom. Okay, first one. What is the GCF? Let's go to the chat, and whoever writes it first counts as a. What is the GCF of that I'm showing right there? Come on, where are you guys? Somebody in the chat type, what is the GCF? Boom, Emily, you win. Okay, wow, look at all the X's pop up there. Maybe your internet's faster. Whoops, I just showed the list of students there. Hopefully your internet's faster than others or something like that. But Emily, do not answer anymore. You're in. You're in as a winner. All right, so it is X. As you see, I see a whole bunch of people putting that. And then to actually, it does say factor it out. So we are going to actually factor it out, not just list it. And then I think I said this before. You don't have to worry about it today, but in the future, this may very well be factorable as well. And I'm going to teach you today how to factor this. And actually, this one's not factorable. So, but don't worry about that. You're only factoring GCFs in this section. Okay, next. On the chat, Emily, you're out. So I should make a note of that, who went first. I just want to get more people in there. Next. Okay, remember, we do want to factor out a negative. Go ahead and write that one down in the chat, and we'll see who's out on this one. All right, yes, it's negative. And someone put negative 4x cubed. Oh, you got to get used to different variables here, man. And it's y's, so technicality, well, how rough that is. All right, so when you take out a negative 4 out of a negative 16, that's 4, and then y to the third. Go ahead and distribute it back in. Yes, I'm good. Minus, because I put out a negative there, 7. And then this is a y left over. Y times y to the third is y to the fourth. And then plus, because I took out a negative. And I believe it's just 5. And then here's another thing. What if someone put 2 or negative 2y cubed? What would have happened is you would have had 8, 14, and 10. And then you would have said to yourself, wait, those are all even. That's not enough. That's not the greatest common factor. So it's a good thing. I'm not making fun of whoever put that on the chat. It's a discount double check again. Again, when I say this word over and over again, good distributors are good factors. It's because they actually distribute and check their answer, but also check, did I take the greatest common factor? So it's a good point to make there. All right. Let's get the chat ready. Those two, I don't want to see your name, or if I do see your name again, you're not counted. It'll be the next person. Speed of the computer. Boom, boom. This is actually in your book. Oh, I guess I can't really do this on this. This is actually in your workbook on page 38. Alessandra, yes. Okay, so on page 38, I guess I'll end the contest right there. In your workbook that I gave you in class, they do have these things. Oh, I see now. I see something that happened in the other hour that I'm going to stop this video for. All right, here's the next one. No Alessandra on this one. Ready, set, go. Oh man, they go so fast. Let's see, 4b squared, 4a, 4b, 4A, 4B, 4A, 4B. I think it's Mary Ruff. Resume. Okay, so yes, I had people do this, and you kind of heard it in the video here. For this one, 4 is the only number that goes into both 8 and 28. 8 doesn't go into 28, so that's it, and it's a squared. This one, 2 goes into these, but also 4, 8, 12, 16. 4 goes into these. And that's it. You can't, 8 doesn't go into any of them, 12 doesn't go into 16. This is it. And then 8 to the 5th, 8 to the 4th, it's 8 to the 4th, and a B. And I hope we had that, a to the 4th. I thought that's what I had when I gave someone a correct answer on that. And then this one for sure is x to the 6th, y to the 8th. 15 and 14 have nothing in common. All right? All right, the contest is over real quick. I'll go ahead and do these, and then we'll use this as for note purposes. Okay. So looking at this, and I just wanted to use these maybe as examples and don't have to probably do them all, but looking at these three, and actually I'll give you a minute, maybe do all three, and then we can use this as a, are you doing the right thing? So go ahead and just do all three on your own. I'll give you about a minute or two, and then I'll just go ahead and show the internet. Might be internet, your internet might be faster too, but we'll see. Okay, so hopefully you did take a negative, and it's 3, and it's x squared. And then this one just real fast, this is x squared minus, because you took out a negative, 4x. And then you took out a negative, positive 7. Okay, and then that's it. You're only doing GCFs in 2-4. You don't have to worry about what's called completely factoring. That'll come later. 3 and 9 have 3 in common, but 3 doesn't go into 8, so got nothing there. Oh no, I have an x cubed and an x, so far I have an x, but I don't have an x. Oh my. Y squared, no y. Y squared, I can't pull out a y. Z to the 4th, z, no z. There is no GCF in this. So therefore, this is non-factorable. You will run into that in the book at times. You bang your head like, wait, there's got to be something, and sometimes there isn't. So no GCF for 16. And then hopefully you went large and got 50 here. 50, a hundo, 150. And then a to the 7th, and then b to the 3rd. And then you figure out what's left over. 2 times 50 is a hundo. A to the 7th, gone, b squared. 150 divided by 50 is 3. And then a to the 8th, that leaves me an a. B to the 3rd's gone. Okay? And then that's all we got to do about that. All right, last thing about GCF is I assigned you 35, so I just wanted to make sure you were okay with what we're doing on 35. And there's actually a few answers that you could do here, but they're saying this is the area, and area is equal to, for a rectangle, length times width. So what they want to do is they don't tell you this, but they want you to find the GCF of that area and make that the length or the width, it doesn't matter, and then the width and the length vice versa. But you could have, if they just said these directions as is, you could have had any common factor pulled out as long as the width represents that correctly. So I guess with the directions, multiple answers could be there, but go ahead and do the GCF. For 10, 15, and 20, it's 5. A squared, A squared, A. B cubed, B squared, B, B. Then that makes the width, length times width, a polynomial of 3 terms. What's left over? 2A, B squared. Because length times width, you'd have to distribute this in order to multiply length times width to get area. Plus, hopefully I have enough room here, 3A, A and an A pulled out, nope, so no A, B squared B, B left over. When I multiply that, does that equal that? That's what I mean about good FOILers, good distributors. I don't care that I'm saying it over and over again. All right, hammer that in your head that this actually is not bad stuff. I don't know why factoring seems to be a problem over the years. So hopefully we're good here, and then we're going to move on to the next factoring. Here we go. On the chat, answer this question First person, except for the 4, there are 5 that you already won. I just want a smattering of different people. Although you guys are doing a lot better than second hour as far as a lot of people answering in the chat. Ready, set, go. Answer that question. And I'll tell you why in a minute. Matthew, got it. Nice. Check, baby, 1, 2, 3. All right, next one. Matthew, you're canceled the rest of the way. Just want to get a smattering of people. Boom. Next one, guys. Ooh, same number. Multiplies to be 15, but then adds to be negative 16. Somebody new. Nice, Ethan. Negative 3. Oh, no, that's not correct. Sorry, I spoke too soon. Sorry about that, Ethan. What multiplies to 15, but then adds to be negative 16. Interesting. Nice, Carolina, negative 1 and negative 15. Yes, this is cool. A few others chimed in, but Carolina got there first, I believe. Boom, next one. Wait, this is the same. Oh, it's negative 15. Then adds together to be negative 2. Negative 5 and positive 3. A lot of people put negative 3 and positive 5 first. Yes, good. Then the last one, boom. Multiplies to negative 15, but adds to negative 14. Little check marks for those that get it done first. Again, hopefully it's not just because your internet's faster than some others, but yeah. And guess what? That whole thing is the key to factoring these kind of polynomials up here. Trinomials that have a leading coefficient of 1 and are in what's called quadratic form, x squared, x, and then a constant. But then when we end the set of notes, I'm going to put a real complicated one that is in quadratic format, but it's more than an x squared. And after we get through the trickery of this, it is kind of a trick how we do this, but it's not. Remember when I was foiling? I told you after we're done foiling, here's what we did to foil. We did first x squared, 3x, 2x, first, outer, inner, last. Last is 2 times 3. And then we got the answer by adding the like terms. And I said, here's your answer from section probably 2.3. And then I said, hey guys, later we're going to be asked to factor this. And that is the answer when we factor it. It's just the reverse of multiplying. And that is what section 2.5 is all about. 2.5 is getting that answer from this. So I love how the book breaks this down because it's exactly how I break this down in the past in teaching this. How do we analyze how to factor this then? Obviously, we see the answer. So what actually happens? Well, what actually happens is this. This number right here, 6, I guess I should erase this if I could. I lost my ability to write here. Good. Computer, come on, my pen. There we go. This number right here, notice the relationship between that number and these two. And the relationship is 2 times 3 equals 6. And then notice the relationship between this number and these two numbers, or those same two numbers. I don't want to over highlight the yellow. And the answer to that question is those add to be that middle number. That's why we went through all of this. This ability to do these little numerical things, what multiplies to this number, and at the same time those same two numbers add to this other number, is the main idea of how to factor a trinomial with a leading coefficient of 1. Very specific to this type of thing. So I will put this, and feel free to write this, but we will never write this like this again. Just like I said, this last term C is equal to the product of those two factors in that binomial. I will always just put an M above this number. That is our multiply number. And then yet again, those two numbers added together always end up equaling RB. This pen is being very naughty right now. Those two numbers added together end up being your middle term, okay? And it works. Good FOILers are, good factors. Go ahead in the chat. Put the factored answer using parentheses of that first question. Waiting for someone in the chat, still waiting for someone in the chat to put the answer, trying to look up and down. Remember, this is your M number. This is your A. Still waiting for someone in chat to put the factors down, knowing that, okay, this breaks down into a binomial x plus or minus something times x plus, because x times x is still x squared. Good FOILers are good factors. And then what are the two numbers that multiply to 36 and add to 13 and end up in these parentheses? No one in the chat? Did the chat freeze? Did everyone leave? Got your name offline there. Now we're back online. Yes, we had somebody go in there and get the answer. Now, I'm going to explain this. You feel like, wait, what just happened? How come I don't know how that's the answer? You should. You know why? Good FOILers are good factors. If I multiply this, yes. If I take last, 9 times 4 is 36. There's the M component. Here's the A component. I'm going to change that to a green A. 4x and 9x. That's outer and inner of FOIL. 4x plus 9x does equal 13. So good FOILers are good factors. Hopefully we learn to factor fast. And then we have extra time to check our answer. Okay? All right, so we'll leave questions at the end. We're going to keep going with this game. Get ready. This hopefully goes faster. On the chat, go. In here. But it also gives me a good representation that at least I'm reaching out to some people, if not everyone, but I know some may not be able to type as fast as others too, and maybe your internet's a little clunky at home, but x times x, sure, x squared. 4 times 7, sure, 28. I always check first and last first. Sometimes we have some signage errors, and we know that we have an incorrect answer right away. But anyway, 7x and 4x is 11x. So yeah, if I FOIL that and get the question, then I factored it correctly. Circle them up, and we're good to go. Boom. Okay, we'll just do the first one on the chat, and then the second one I'll just cover as an example. Ready, set, go. Just write the first answer, and then I'll do the second one. First answer on the chat, negative. Okay, so good. In the chat, we're only going to do that first one. It's -3 minus 5. Again, when you're factoring with a leading coefficient of 1, put an M above this and an A above that. Do not ignore the minus sign, so that we understand that. So x squared, good. Negative 5x, negative 3x is negative 8x, good. Negative times a negative is a positive 15. Good FOILers, good factors. Don't care if you're getting sick of me saying that. Then the last one, these are, questions when you have a negative middle term, then you need a negative and a negative. It's a good thing to think about that. And then what multiplies to 42, 7, and 6? So it's x minus 7, x minus 6. Okay? So again, this is what I talk about being numerate. 6 times 7 is 42, right? As I say that. And then the middle term is negative 7x and negative 6x, okay? But being numerate, understanding your times tables, but also understanding the multiplying aspect. Next one, first one on the first one, letter A only, just because I don't want to blacken out. Keep in mind, good FOILers are good factors. We had our first answer where it was switched. It is what multiplies a negative 14? 2 and negative 7, and it's got to be that because our middle term is negative. And then just let's look at outer and inner. 2x plus negative 7x, okay, is negative 5x. So if you switch these, that does not lead to the answer that we have up there, or the question. Okay, so just make sure, and then I see a couple other in the chat, the signs are off. So be aware of that. You check your answer. I know you're trying to rush on the chat, but once you write an answer, you better make sure that you do get the middle term, otherwise you made a mistake. Okay, and I do see a couple mistakes in the chat, which is okay. That's part of what we're doing here. We're learning. Then this last one, x and x, and then what multiplies a negative 16 but adds to a positive 6. Well, now we have the bigger number positive and the smaller one negative. Make sure that that works. Negative 16 there, x squared here, then negative 2x and positive 8x. Yes, that's positive 6x. Okay, I think I'm getting close to being done. No. Okay, now here come the more complicated ones. Don't worry about writing this down. I'm just going to teach this and end the lesson. Okay, don't freak out. And then actually I have a real big monster after this that's hiding in the red. Don't freak out about this. This just means, okay, think about that x squared there. That has to be x and x because x times x is x squared. So what has to happen over here? It's got to be some y and some y because y times y gives me a y squared. But wait a minute, what about that middle term? Well, let's analyze the middle term real quick before I even write the numbers there. That's x times y, and that's x times y. So I will get a middle xy term. All right, that will be the variables attached on that. So ultimately what I'm saying is you just have to M32 A12. What multiplies to 32 and adds to 12? Both positive numbers. And hopefully the numerate people understand right away that that's 4 times 8. Again, you know, the numeracy of this really plays out. Knowing that 4 times 8 is 32 so fast, and then 4 plus 8 is actually equal to 12. And then you should be, as a good foiler, understand that x times 8y is 8xy. 4y times x is 4xy. These do add to be a 12xy. Good foilers? Anyone? 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 What have I said a million times? Put it on the chat. Good foilers are? Nobody's putting it on the chat. Maybe it goes too slow. Nice. Nice. They're like, oh, look at them all. Good distributors, too. I like that. Yep, good factors, good distributors. Well, I said good foilers, I guess so, but it's really good distributors are good factors, good distributors. Yeah, okay. Anyway, and then this last one, hopefully you get it. All right, so it's just an x and a y times an x and a y. Now we'll get to the monster. Okay, I have a positive product and a negative sum. That means these both have to be negative. That's kind of the breakdown that they had up there with our little game that we played. And obviously it's 3 times 7, but it's 3y times 7y. Okay, x squared, yes. Positive 21y squared, yes. Negative 7xy and negative 3xy, negative 10xy. Good foilers, good factors. Okay, here's the monster. Rawr. Be prepared to be scared. And then we'll shut this down after I'm done with this example. Maybe. There we go. Ah! Hopefully someone screamed like that was a scary little question there. What is going on with this? Oh my goodness. He said quadratic form, which meant this was an x squared, an x, and a constant. This has a whole bunch of stuff. But it is a trinomial, and it is in quadratic format. And it is a trinomial. So these are about recognition of how am I going to factor as I move through this chapter and I learn more things. Ryan, I'll get that question in a second here after I'm done. This is the last example. And then I'll actually open up the mic for anyone that has questions. Okay, so how does this actually work? Well, hopefully we understand our exponent rules and understand that to get x to the 6th, the first in FOIL would have to be x to the 3rd times x to the 3rd. So far I'm good. And then hopefully you understand for the last in FOIL, to get y to the 8th, this would have to be y to the 4th, and this would have to be y to the 4th. I'm good. That gives me y to the... Wait a minute, this middle term, this is goofy. Oh, wait. If I take x to the 3rd times y to the 4th, I get an x cubed y 4th. And if I take a y to the 4th times x to the cube, I get another x cubed y to the 4th. And lo and behold, that is what my middle term has. So wait a minute. All I have to do then is m negative 56 and a negative 1 on the chat. What two numbers multiply to negative 56 and at the same time add to negative 1? Then I'll pause the video until I get that number. Okay, good. Someone on the chat got it. One came close, but they had their sign switched. It's minus 8 plus 7, because negative 8 plus 7 is negative 1. Don't miss that when you're doing these breakdowns. And then now what I can do is, okay, Yeah, that middle term, that green line from x cubed to 7 y to the fourth, that'd be positive 7y to the fourth, and this would be negative 8. So this does add to that middle term. So I know I got all these arrows going all over. This is your brain. You shouldn't have this written all on your paper. These are your checks to make sure that your answer actually makes sense. That is the answer, though, in factored form. Everything else in all those lines were checking. Okay, we're good. We ended up at over 30 minutes, but trying to do a lot in class as well to get you involved. Hopefully you enjoyed the lesson. Oh, I will say this too. I did cut, I can leave this if you wanted to look at it. This just breaks down everything that we just went through. And I love number 39. So I'll leave this up here for you to read. I'm not sure if you can find it in your book, probably in the examples, so on and so forth. But just break this down. Look at the last numbers, 14, one of them negative, and that produces a whole bunch of different possibilities for factors depending on what the middle term is. But really breaks down MA and how you break those numbers down. 39 is an awesome question that actually really breaks that down as well.